Hello.
Hi, Celine. How are you? Celine, can you hear me?
Yes, sorry, because my computer doesn't work well, so yeah, sometimes it's lagging, that's why.
Okay. Celine, is it possible to see your face? Are you joining with
Yes.
computer or with telephone?
Now I'm on computer. Okay, now.
Yeah, if possible, if your connection is good, let me see your face because you are the only one here.
Okay. Can I send you my homework now or after the lesson?
Okay, after the lesson. And also, I'll just tell you how to do your homework and how to send it to me and how to save it with what name. Okay, so could you do all the questions?
I didn't finish yet the exercise 1F third one and the last ones because like you sent it yesterday.
Okay.
And yes.
Okay, it's no problem. But Selen, how is your the questions? I mean, can you do all the questions easily, or do you struggle with any questions?
I struggled with exercise 1D of fifth question, 6 and 7th. The word problems are a little bit of hard to me. That's why.
Okay, very good. It's nice, Selen, no problem. Okay, just keep doing this. The questions that you struggled, or maybe completely, if you don't understand, you can just put question mark. And maybe after I teach like 20-25 minutes, and after that we may have some discussions together. Okay, we can actually discuss those questions together and try to solve every question. And of course, you don't have to write every step. You know, sometimes you just see the question. For example, what is the highest common factor of 20 and 30? Right, these questions, even you can answer quickly, right? 20 and 30, the highest common factor is 10. So just write 10 and continue. Some questions maybe you need to work out, like 276 and 350, for example. Immediately you cannot actually answer this question mentally, right? So this question maybe you can just write in the paper and go through all the steps. Okay, so Selen, let's continue. Let's do some questions, maybe like 20 and 30 minutes. After that we will have some break, maybe 5 minutes. And after that, if you have any questions, I will try to answer your questions. And that's it for today. We will see how much we can cover. So last time, we actually started this course with factors and multiples. And when we talk about factors and multiples, as you know, we are talking about natural numbers, right? These are 1, 2, 3, 4, 5. So here we have a few questions similar but a bit different. Maybe by solving these questions you will have some idea. So anytime if you don't understand, you can just stop. Okay, Mr. Kasim, this step I didn't understand. Why actually are you doing this step? You can ask. Okay, because here you are the only one. If we have more students here, like we are expecting some more students, if we have 4 or 5 students at that time, I may give you different section for discussion, because if students ask questions every time, it may not be so efficient. Okay, now you are the only one student. Anytime you just stop and you can ask me. Okay, so Selen, let's continue them here. Okay, let's choose different color. Find the smallest value of k when 264 is a perfect square. Perfect square. And the second question is 196k is a cube. This is also related to factor and what is it? multiples. So here, question A, the smallest value of k, when 264 times k, it should be a perfect square. What is perfect square? It's the square of some natural number, right? Let's say it is the square of some natural number. What is m here? M is a natural number. Let me just, like this, okay? And I don't know if you understand this one. This m belongs to n. What does it mean? Actually, this n is a kind of folder name. And in math, we call this set, right? The set actually contains these numbers. These are 1, 2, 3, 4, dot, dot, dot. These numbers. What is m? M is an element of this set. M can be maybe 1 or 2 or 3, any number from here, right? So now to answer this question, first, 264. What are the prime factors of 264? Let's just find prime factorization of 264. Because as you know, that's to be a number, right? A perfect square. For example, let's say 16, right? I can write 16 as 2 to the power 4, right? So actually every number, this index, actually we call this index or exponent, it must be even number, right? For example, if we have something like this, m squared, if we have, the index notation is something like this, 2 to the power 4, 3 squared, maybe 5 to the power 6. So actually looking at this, can we just say that this number, whatever it is, let's say this number a, that's equal to m squared. How do I know that it's a square number? Because I can just write here, this 4 is an even number, 2 is an even number, 6 is an even number, right? All these indices are even numbers. That means that it is a perfect square. So the idea is this. So if we find prime factorization of 264, divide by 2. So here we have 1, 3, 2. Divide by 2. Here we have 6, 6. Divide by 2, 3, 3. Now it's not divided by 2. I can divide by 3. So here we have 11. And divide by 11 because the prime factor, prime number, it is 1. So here, 264, if I just write 264k, so this part 264, what is it? How many 2's we have here? 3. So I can write it as 2 cubed times 3 times 11 times k. Now, Selen, question for you. What do you think about the value of k? What is the minimum value of k? And here I'm hoping that this should be a square of a natural number, right?
So I need to multiply 2 by 3 and by 11 and then 264 minus,
No.
right?
Actually, here the question is find the smallest value of k, so that this number, right, 264 is a perfect square. So to be perfect square, all these indices here, what is the index here? 3. And what is the index here? It is 1. What is the index here? It is 1. So actually these indices must be even numbers, right? Otherwise it cannot be a perfect square. So how can I make them even? This k, I don't know actually. I need to substitute such number for k so that it makes these indices, what is it, even. So now think about this number. For example, how about if k, here we have 2 cubed, right? If this one is multiplied by 1 more 2, it will be 2 to the power of 4. Okay, here it must contain 2 and 3 to the power 1. We need 1 more 3 to make this square. So also 1 factor of k must be 3. And also 11 to the power 1, to the power of 1, also actually 11 must be 1 factor of k. Now if I substitute this value for k, what happens here? So it's 264k, and 264 is 2 cubed times 3 times 11. So for k, I substitute this number. It is 2 times 3 times 11. Now, if you simplify here, 2 to the power of 3, here we have 2. So here we have 2 to the power
2
of
to the
4,
power
right?
of 4
And
and
here we
3
have
to the
3,
power of
3,
2
3
and
squared,
11.
and 11 squared. Now in math, I'm just going to use this rule. As you know, for example, 16, right? I can write it as 4 squared. What is 4 squared? It is 4 is 2 squared, and here we have squared. And also like this, when things are multiplied, I can just write here 2 squared and 3 times 11, and here we have the whole squared. This square belongs to each, right? 2 times 2, it is 4. Index, 1 times 2, it is 2. 1 times 2, it is 2. So that means that now I can write it as 2 squared, 4 times 3, 12, 12 times 3, 132. So here we have 132 squared. So actually to make this expression, that number 264k, a perfect square, the value of k must be this number. What is it? Which is equal to 66, minimum value. We have a lot of numbers that makes it perfect. For example, another value, okay, that's the answer, but the question is for you, Celine, can you show me, here it says smallest, right? If I just delete this word from the question, can you show me another k that makes this number, that makes this 264k a perfect square? Here, again, we need to write the prime factorization of 264, right? 264, not 264. What is it? It is 2 cube times 3 times 11 and k. So k should actually, the factors of k must be such numbers that makes 2 cubed. I mean, this one even, and also this one even, and also this one even, right? For example, what number can it be? For example, this k can be 2 squared times 3 to the power 3 times 11 to the power of 3, right? If you substitute here, what we have here, if you just combine this, 264k at the time will be 2 cubed times 3 times 11. And instead of k, if you substitute this thing, 2 cubed times 3 cubed times 11 cubed. Now, if you simplify this, here we have 2 cubed, 2 cubed. So here we have 2 to the power of 6. And 3 cubed, that is 3 to the power of 4. And here we have 11 cubed, that is 11 to the power of 4. As you see here, now all indices are even numbers. 6 is even number, 4 is an even number, 4 is an even number. So I can just write it as 2 cubed times 3 squared times 11 squared, and here we have squared, right? And inside, actually, we have a natural number, 2 cubed, 3 squared, 11 squared. If you multiply them together, we get a natural number. And outside, we have one more square. That means that it is a perfect square. But actually, we have a lot of numbers. But here, that's why asking the smallest possible number. What is the smallest possible number that makes a perfect square? It is 66. Did you get the idea?
Kinda.
Okay, now let's do the second question. Maybe you'll get more idea. The second question is 1960k is a cube, right? So immediately using this idea here, let me just find the prime factorization of 1960. 1960, draw a line. Let's start dividing by 2. 2, here we have 9, 16, it is 8, 0. Again, you can divide by 2. Here we have 4, 18. It is 9, 0. Divide by 2. Here we have 2, 9. Here we have 5. 2, 9, 5 is not divisible by 2 anymore. Is it divisible by 3?
By 3, no.
It's not divisible by 3, right? Because to be divisible by 3,
5.
the sum of the digits must be divisible by 3. 2 plus 9 is 11. 11 plus 5 is 16. 16 is not divisible by 3. That's why it's not divisible by 3. So next prime number is 5.
5.
And since the last digit is 5, it is divisible by 5. If you divide by 5, here we have 5, 45, it is 9. Emma, how about 49? Is it a composite number or prime number?
59.
Yeah. It's a prime number, right?
Yes.
If you remember, because not divisible by 2, it's not divisible by 3, it is not divisible by 5, and also it's not divisible by 7, and it's not divisible by 11, so you can stop. So it's not a composite number, so it's prime number. So the only number that divides 59 without leaving any remainder is 59. So here we have 1. Am I right?
Mm-hmm. So 2 of power of 3 multiplied by 5.
So here, now I can write, let me just write here, we don't have a space, 1960K. And prime factorization of 1960 is, what is it? 2 cubed
2.
times 5 times 59, right? And here we have times K. And I'm hoping that we are expecting that we should substitute such number for K so that it becomes a cube of a natural number, right? So here we have 2 cubed, no problem. So actually this K must be, what is it? 5 squared times 59 squared, right? Because if you substitute here, 5 times 5 squared, it is 5 cubed. 59 times 59 squared, it is 59 cubed, right? At the time, I can just write this number as 2 times 5 times 59, and here we have cube, which is equal to 2 times 5, 10. 10 times 59 is 590 cube.
So K is...
So K is, what is K? It is 25 times 59 squared. What is 25 times 59 squared? With long multiplication, we can find this. 59 squared times is 25. That's equal to 87,025. So that is the smallest possible value of K. Actually, that makes that 1960 times K a cube number. Okay, and sometimes the number may be very big or very small, it doesn't matter. We should not be afraid of, how to say, dealing with big numbers or small numbers, but in real life, we have a lot of very huge numbers, right? Or very small numbers. If you are measuring, for example, gold, right? Even very small number is very important because 1 gram of gold is about $25. Or how about 1 gram of diamond, for example? So there, even small numbers are really important. If you're talking about the distance between the Earth or planets, right? At the time we are using very huge numbers. Anyway, Celine, I think you got some idea. There are some questions similar to this in the exercises, okay? You try one more time. Still, if you don't get it, we can solve some different questions. So can you read the question?
Yes. A. If 1764 is 2 by 3 by 7p, find the value of p.
Okay. Now tell me, what do you suggest? How can we solve this problem? What is the first step?
Multiply all the numbers.
Okay, if you multiply this, 2 times 3 is 6, 6 times 7 is 42. Then?
42. Then I need to find the square, no, cube of the number 1764.
Okay. I also, that is one way, but instead of this, as you see on the right-hand side, this 2, 3, 7, all of these numbers are prime numbers, right? So how about if we find the prime factorization of 1764? So that's much better actually to find the value of P. Otherwise, also your way is good. Like you are saying that 1764 on the right hand side, 2 times 3 times 7 is 42 to the power of P. Maybe here you can see that I think P will be 2. If P is not a natural number, something different, for example, it will be a bit hard, right? How do you find P from here? So it's a kind of logarithmic equation, this one. We can solve this actually. It is not possible. You can solve this, but you need to use some different concepts, which you are going to learn in grade 8 or 9. Anyway, Salen, let's just use our knowledge that we got or that we learned in the last class. So 1764, let's find prime factorization of this number. Divide by 2. Here we have 8, 16, 8, 2. Divide by 2. Here we have 4, 4, 1. Now it's not divisible by 2 anymore. How about 3? Yes, because 4 plus 4 plus 1 is 9, right? The sum of the digits divisible by 3. So this number is divisible by 3. If you divide by 3, 4, here we have 1, 14, here we have 4, 21, it is 7. Still, it's divisible by 3. It is, what is it, 4, 27, it is 9. And just 49, we know that it's 7 squared. We can divide by 7. Here it is 7, divide 7, and 1. So 1764 is equal to 2, 2, 3, 377. That is 2 squared times 3 squared times 7 squared. And see here, all of these indices, actually their common factor is 2. We can just write it as 2 times 3 times 7 to the power of 2. What we have on the right hand side? We have on the right hand side, we have 2 times 3 times 7 to the power of P. Now from here, what is the value of P? It is 2, right?
Mm-hmm.
Okay, how about question B?
Given that 1764 and a number Q has an LSM, a least common multiple of 8820 and a highest common factor of 36, find the number Q.
Selene, can you write on the screen? Do you have a pen?
Yes, I have a paper.
No, on the screen. Can you write on the screen?
I don't know if I can because my computer is too old and I can't really use computer.
Yeah, how about, do you have the tablet or iPad or something?
Yes, I have iPad, but it has no battery and I have phone.
Okay. Maybe next time, Selene, if you can actually connect with PC, and also if you join with your iPad, if you have a pen, if you can write, okay? Because in Zoom, if you just click this, we have annotate, right? If you click on annotate, you can write on the screen. And sometimes if you just write, I can have
One
you.
second. Where do I need to click? In the
Uh,
Zoom, not in
yes,
the other app.
yeah, Zoom, when you just click this, you see annotate. You see the picture of the pencil or pen in the bar.
One second.
Here we have security, participants, new share, pause, annotate, remote control. Can you see annotate, the picture of the pencil?
No, I don't have it.
Yeah, actually Zoom has it.
Okay, I'm gonna join the lesson.
Okay, there we have annotate,
Okay.
and after that you can write on the screen. All right, let's continue then. Question B. Let's solve question B. Did you understand the question, Selene? Here it says that given that 1764 and the number Q has an LCM of 8820, that means that LCM, least common multiple of 1764 and the number Q, right? We don't know what is that number. That's equal to 8820. Who is writing here? Is it you? I don't hear you. Why? Hello? Hello, what happened? You can't get
I don't
connected?
know. My computer, I don't know why it does.
Okay, try one more time. If it doesn't work, you'll continue like this. Or you just sign in with your computer. Two people are okay. Yeah.
Do you see me?
Yeah, I can see you now. Okay.
Mm-hmm.
Good. So this is a question 176, and we have already found it is prime factorization. And also we have another number here that is Q. And it says that least common multiple of these two numbers, 1764 and Q, it is 8820. Okay. And 1764 and Q, that is 36. The question is, what is the value of Q? What is that number Q? What do you think? How do you answer this question? Now, how would you solve this question?
Um, I think I need to find the common multiples of. No, I need to find the multiples of 1764 and
Okay.
factors.
Here we have already found in question A, right?
Mm-hmm.
Okay.
And of factors, if I'm not mistaken.
Factors of what?
I'm gonna write. I'm gonna write the solution. 764. So 1764 and Q, and the number Q has an 8. Can I write there? Can I write on the board?
Yeah, of course.
Okay, so if 1764 and something, the Q is 8,820. I need to find LSM, right?
Mm-hmm.
I need to find of both of them multiples.
Yeah, usually the idea of common factor, what is it? When you just write 1764, that is 2 squared, and here we have 3 squared times 7 squared, right? And how about Q? We don't know, right? And when you're finding the highest common factor of these numbers, we just get the smallest value of this one, right? So that means that for sure this Q, this 2 squared, it's also the factor of Q. And this 36 is it is like 2 squared times 9, that is 3 squared. And also the 3 squared is the common factor of q, right? So that means that it has this 2 squared and 3 squared, but it doesn't have this 7 squared. And how about when you're finding the least common multiple, you will get the maximum value, right? How about, let me just write here, 1764, and here we have q. We need to find the least common multiple of these numbers. So here we have 2 squared, 3 squared, and 7 squared. And how about q? Since it has 2 squared, 2 squared, and 3 squared, 3 squared, maybe it is more than this, we don't know. And actually this 7, it is not factor of q, right? So what is 8820? When you just write 8820, 8820, okay, now I got it messy. Let me just write here. 8820 divide by 2, 4410, divide by 2, 2205, divide by 5, it is 420, it is 41, and then divide by 3117, no, divide by 3, 114, it is 421, 7, and divide by 3, it is 4, 9, divided by 7, here we have 7. Okay, so what is this? This 8820, here we have 2 2s and 1 5, 3, and 2 7s, right? As you see here, in 1764, we have 2 squared. We have 2 squared, no problem with this. We have 7 squared. Okay, we have 7 squared, no problem with this. And 3 squared also we have. What is missing here? Only 5, right? Is it?
Mm-hmm.
So that means that's okay. That means that what?
Q is 5.
It means it's 5. I mean, no, 5, 7 squared. Okay. All right. All right. That thing is 2 squared, highest common factor, maximum. Okay, we are taking this 2, this 2, this 2, also 5. Okay. So this Q also it has 5. All right. And okay. So what is the value of Q, Salim? Is it 5 times 36? 180.
No.
No? Are you sure?
I think no, because there's like no.
Look, if I write this,
I messed up a bit.
Look here. If I write Q here, 180, for example, this 1764. Let me just write here 2 squared, 3 squared, and 7 squared. And how about 180? That is 2 squared times, this is 4 times 9, 3 squared times, here we have 5, right? And how do you find highest common factor? To get the highest common factor, this 2 squared, 2 squared, we need to get the smallest of these numbers, right? 2, 2, the smallest is 2. So here we have is just 2 squared. And smallest of this one, also here we have 9, that is 3 squared. And we don't have 7 here, we don't have 5 here. So that's equal to 36. And how about to get the least common multiple? Now we get the maximum of these indices, right? So that is 2, 2. So here we have 2 squared. Maximum of this, it is 3 squared. Maximum of 5, because here we have 5, here we have 5 to the power 0, here we have 5, and here we have 7 squared. which is equal to 8820. So the value of Q is 180.
Okay, again.
Because this Q must be divisible by one, must be divisible by 36, and also this 5, as you see from here, this 5 must be a factor of Q, because here 5 is not a factor of this number. And there's another method I'll show you a bit later. Just here, I'm just trying to understand how we should get this. Huh? Okay.
I got it finally. Yes.
Okay. Sally, let's do these questions. After that, you'll have some break. Okay, 5-minute break, and also I'll drink some water. You can read the question. It's just warm-up questions.
My copybook. Okay. Say whether each of the following is true or false. True or false. Okay.
Okay.
A. The prime numbers between 1 and 20. 1 and 20 are 2, 3, 5, 7, 9, 11, 13, 17, and 19.
Is it true or false?
One, two, three. It's true, I think.
True. Are you sure? All of these numbers are prime numbers?
I'm not sure about 5.
5 is prime number. How about 9? What are the factors of 9? It is 1, 3, and 9, right? It has more than 2 factors.
Yes. And 19?
And 19 is prime number. Its factors are only 1 and 19. And 17, only 1 and 17. Prime number means it has exactly 2 distinct factors, right? The only number which has more than 2 factors is 9. It has 3 factors. That is a composite number. It's not a prime number.
Then it's false.
It is false because 9 is not a prime number. If we delete this 9, then it would be correct. Because of this 9, it is a false statement. How about B?
The highest common factor of 16, 20, 24, and 32 is 8. No, this is false, I think, because of the 20.
That's right. 20 is not divisible by 8, right? That's why it is a false statement. How about C?
The smallest number that is divisible by 10, 15, and 20 is 60. No, I think because the smaller is 6.
No. The smallest number that is divisible.
Oh, then it's true.
Yeah, if you say that the smallest number, if you say the smallest number that is divisible, not divisible, that divides, it's 1. 1 is the smallest number, right? It divides any number. I think you got confused with highest common factor. Okay.
Yeah, a bit.
Yeah, for your answer, if I say that the greatest number that divides these numbers is 60, it would be wrong. It will be 6 now. The greatest number that divides, right? This, but here it is divisible. So that's why it is correct. Because 20 multiplied to 20, it is 40, 60, 80. 40 is not divisible by 15, but 60, it is divisible by 20, 15, and 10. Good. How about D?
1725 when expressed as a product of prime factors is 23 by 15 by 5. Can I count on the paper?
No, you don't have to count. Just look at this answer. You don't have to do anything. This is a bit tricky question. Here, Salim, what is it saying? The question is saying that 1725, when expressed as a product of prime factors. What does prime factors mean? Here, all numbers must be prime numbers, right?
Factorization.
Yeah, but here, are all these numbers are prime numbers?
No, 23 is not, no, 5.
No, this 15 is not a prime number, right? Because it's 3 times 5.
Okay. Yes.
If they ask like this, for example, if it was like this, 23 times 5 times 3 times 5, then it would be correct. It would be true because all of these numbers are factors and they are prime numbers. But here it's saying that prime factorization, that means that all factors must be prime numbers. But 15 is not a prime number. That's why it is false. How about E?
The highest common factor of 4 multiplied by 3 power of 2, 3 by 4 power of 2, and 2 by 3 by 5 is 4 power of 2, and 3 power of 2, and by 5.
Here is the first number.
No, it's false,
number,
I think.
third number. The highest common factor of. True or false? False?
I think false.
You think, so you're not sure. Why? If you just write here, we have 4 times 3 squared. The second number is 4 squared times 3. And third number is 2 times 3 times 5. To find the highest common factor, right? Actually, here, these are the powers of 2. We need to get the smallest one, right? The smallest one is 2. And here also the smallest one is 3. And here the smallest one, only 5, it is 5. That's the highest common factor. But here, this guy is taking the biggest of these numbers, right? From here, the biggest one is 4 squared, so he got 4 squared. From here, the second column, the biggest one is 3 squared, he got a 3 squared. And third column, the biggest one is 5. Actually, this one is, what is it? LCM, right? But here it's saying that HCF, that's why it is false, right? Because you have to be sure, actually, when you're saying that, okay, it is false, why? Because of this fact, right? It is true, why? Because of this reason. Okay, how about F?
Um, 2,000 and 900. I think no, false.
Because here square root, right? This 800, we can write it as square root of 800 squared, which is equal to 640,000. And how about 900s? We can write it as square root of 900 squared, which is equal to square root of 810,000. Right? Now look at this. Celine, the first one, 800, is square root of 640,000. And the second one is 810,000. But here we have 802,500. Do you think this number is between 800 and 900?
No.
Yes.
Why? But there's like 64 and there's 81.
Okay, but what is 80? 80 mean 800 means square root of 640,000, right? This 802,500, is it greater than 640,000?
Yes.
Yes, then I can just write like this, right? 800 is less than square root of 800, 2000, and 500. Now, 800 and 2000, and here we have 810,000. Is 810,000 greater than 802 and 802,500? Yes. So here we have, what is it? 900. So that means that this number lies between these two numbers. Because if you take square root of 800, 2,500, it will be between 800 and 900.
Okay, I got it.
And how about G?
G, an approximation of 82 power 2
89.
is 8 or 89 uh, is
Celine,
8,100, which is less than exact.
okay, Celine, why are you also it's simple? You can just read it as when it is 289 squared. That is much easier.
Oh, yeah. An approximation of 89 squared is 8,100, which is less than the exact value of 89 squared. So 89 squared.
Now, Celine, if I ask you a question, okay, without using calculator, can you actually estimate, approximate, what is the approximate value of this? How would you approximate this? You approximate with 90, right? Because which number that ends with
I can
0?
multiply 89.
I can approximate 89 with 90 squared, and 90 squared is 81100. So actually we are approximating 89 with 90. But can you just tell me now, 89 squared, is it less than 81,000? Okay, no, not 81,000, it's 8,100.
No.
Yes. Because you're approximately 89 with a number that is greater than 89, right? So that means that from here, 89 squared is less than 8100. Because in the question it's asking an approximation of 89 squared is 88,100, which is less than the exact value of 89 squared. Actually, this 88,100 is not less than the exact value, right? It is greater than the exact value of 89 squared. Okay?
Okay.
Okay. All right, continue, Selin. Find the highest common factor of each of the following. Salin, I think you can do them, right? Let's just do only one question. I mean, just recap for what we have learned so far. Let's just do only one question. C. Salin, tell me, I will write. So just dictate and I will write here. Draw a line. What should I do in the first step?
Find the factors.
I mean, start dividing by the smallest prime factor, right? So divide by 2, because it's 104 is divisible by 2. 65, we cannot divide this. If you divide by 2, it is 13. 9 divided by 2, 52. It is not a common factor of these numbers, so we have nothing to do with this. Now, all of these numbers, again, 52 divisible by 2. So here we have 65, 39, and 26. So it's not a common factor. Divide by 2, 6, 5, 3, 9, and 26. I'm sorry, 13. So now I can see that these numbers have a common factor, right? What is a common factor? It is 13. 13, so we just put a star here. So it is 5, this one is 3, this one is 1. Actually, these numbers, they don't have a common factor anymore, so I should stop here. So the common, I mean, the product of common factors, it gives us the highest common factor, right? Dot, 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 then highest common factor of these numbers, 65, 78, and 104, that's equal to 13. Are you solving questions like this or in different way?
I actually do the same, but not like the line and all the numbers. I do separately.
Um, okay, whichever is easy for you, you can use that method. How about LCM? I don't know, for me, writing in columns, it looks more comfortable. And also let's just see, here we have 42 and the 63 and 105. So divide by 2, here we have 21, 63, 105. Because first, we need to divide by prime factors until we have 1 here, right? And the product of all of these numbers here, it gives us the least common multiple of these numbers. So now we can divide by 3. If you divide by 3, here we have 7, 21 by 3, it is 35. And now still I can divide by 3, 7, 7, 35, divide by 5, 7, 7, 7, and divide by 7, it is 1, 1, 1. Then list common multiple of these numbers, 42, 63, and 105. What is it? 2 times 3 squared times 5 times 7, which is equal to 2 times 9, 18, 5 times 18, 90, 7 times 90, which is equal to 630. So the answer is 630. Okay,
Okay.
and these are easy questions. Salam, you tell me how we answer these questions, okay? How many whole numbers are between each of the following pairs of numbers? Can you answer question A? How do we know actually how many whole numbers are there between this number and this number? How would you solve this question?
Um, I
Draw
would
a line.
firstly find.
I think I would suggest you draw a number line. Selling, here we have square root of 7, and here we have square root of 80, right? And since we are talking about whole numbers, right? What is the smallest square number that
Like
is greater
this.
than square root of 7? That is square root of 9, right? And what is the biggest number?
Mm-hmm.
Biggest number, I mean, that is, smaller than square root of 80. That number is, what is it? Square root of 64. And the square root of 9 is 3, and the square root of 64 is 8. So what numbers do we have between this dot dot dot? We have 3, 4, 5, 6, 7, and 8. We have these whole numbers between square root of 7 and the square root of 80. How about B? In similar way, Silent, we draw a number line. Here we have, let's say, cube root of 7. And here we have, let's say, cube root of 215. So the smallest cube number greater than 7, that is 8. So here we have cube root of 8, right? And cube number that is less than 215, what number is it? 5 squared, 5 cubed, 125, 6 cubed, 216. Okay, 215. So what is it? We have only this number, cube root of 125. Because here we have 216, it is greater than this. So this cube root of 8, that's equal to 2. Cube root of 125, that's equal to 5. dot, dot, dot. Now, what whole numbers we have between these two numbers? Those numbers are 2, 3, 4, and 5. Because 6 will be greater than cube root of 215. In similar way, how about C? Draw a line. It's just to visualize this so that you can answer easily. Here we have cube root of 18, and here we have square root of 120. So the smallest square cube number greater than 18, that is 17. So here we have cube root of 17. That's greater than cube root of 18. How about square number smaller than 120? I mean, the biggest square number less than 120, that is 100, right? So cube root of 27 is 3. Square root of 100 is 10. So dot, dot, dot. How many whole numbers we have between this? Those numbers are 3, 4, 5, 6, 7, 8, 9, and 10.
9.
But here in the question, it says that how many? So we can answer here how many? 1, 2, 3, 4, 5, 6. So here we have the answer is 6. Here we have the answer is 4. Here our answer is 3, 3. So the answer is 8.
Okay.
Salim, that much is enough. Today is Thursday. I think I will meet you next Monday, right? After you finish this chapter 1 questions, also I will send you the rest of this question. Maybe we'll solve the next time together. Okay, send it to me. Salim, do you know how to send your assignment, right?
I downloaded the Cam Scanner and
Okay.
I signed up. It's pretty cool app. Yeah. I'm gonna send you the homework today.
Salim, actually, you are solving these questions in a notebook, right?
Yes, in here.
Is it a big notebook? What is the size? Is it A4 size or small size?
It's A5.
A5, it's a bit small. Yeah, actually, if possible, Salim, if you can use A4 size notebook, it will be really good, because when you just take the picture, you know, it will be the standard formats, and I don't know, it looks nice. If you can, it's fine, it's okay. But when you just do it on the A4 size paper and then take the picture, and it will be really good. Anyway, Salim, first you send it to me, your assignment. Okay, let me have a look. After that, I will give you some feedback about your assignment, okay? You just keep doing, Salim, and I will send you another homework, but it doesn't mean that you have to do until Monday. If you have time, you do it, okay? Because now is a kind of revision. I will send a question about integers, because our next topic is integers, okay? Easy questions, you just practice, have a look, so that we can go much faster.
I didn't finish the exercises 1F, the third, and etc. The last ones. Can I finish it and then send it to you today, like in an hour?
Okay.
Okay, thank you.
Good. Okay. Sana, thank you very much. Okay, see you next Monday. Wish you good luck. All right.
Okay.
Okay. Bye-bye.
Bye.